All right, so now we're going to do advertising campaign. And so this says marketing division of a large firm has found it can model the sales generated by an advertising campaign as SU equals square root of 75 or 0.75 times the square root of U plus 1.8 millions of dollars. And when the firm invests $1,000 in advertising, now the firm plans to invest U of X equals negative 2.3x squared plus 53x plus $250,000 each month, where X is the number of months after the beginning of the advertising campaign. So we're supposed to write a model for the predicted sales X months into the campaign. All right. Well, sales is going to be S of U, but we have to predict how much we plug into it. And that's the number of months into it we do. And that's how much we plug in the thousands of dollars. So we want S of U of X. Okay. So that means we're going to plug this into U. And so that gives us 0.75 square root of negative 2.3x squared plus 53x plus 250. And then we have that plus 1.8. And this is going to be all in millions of dollars. Okay. So that was pretty easy. Now write the formula for the rate of change of predicted sales X months into the campaign. So we need the derivative for the predicted sales. So we need the S prime, okay? So let's call it ds over dx. Okay, so the first and the last. So we can have multiple things in here, and we're just doing ds dx. Well, how are we going to do that? Well, first we're going to take the derivative here. So that's going to be ds du. And then we're going to take the derivative here. That's du dx. Okay, and we're just not subtracting. That's supposed to be a multiply. And so we multiply those two together, and that should give us our values. So what do? Well, we just need to take the derivative of both of these. So s prime of u is equal to, well, we'll have a thing times this. Now, if we rewrite that as 0.75 u to the 1/2, that's going to make it a little easier because then we don't have to worry about what is the square root. And so we bring that down, and we'll have 0.75 times, now we have a half, then we have a u, then we have to take half minus 1, it's going to be a minus 1/2, and so the derivative of 1.8 is nothing, and so that should be our first derivative there. Now here, u prime of x is equal to, and that's going to be 2 times a negative 2.3, so that's going to be a negative 4.6x, and then plus 53. Okay, so now we've got our, and remember, this is ds du, and this is du dx, and so we've got those. So now we take 0.75 times 0.5 u to the negative 1/2, and then times the negative 4.6x plus 53. Okay. Now, remember, it's supposed to be ds dx. We've got x here, but what do we have here? We have a u. So what we have to do is resubstitute our original u in place of this one. So that's going to be 0.75 times 0.5 times negative 2.3x squared plus 53x plus 250 to the negative 1/2. And then that's going to be in parentheses and then times a negative 4.6x plus 53. Okay. And so if we leave it as that, then we would have a function we could use. That's going to be our ds dx, and that's going to be in $1 million per month. Okay. Now we could simplify it. We could take 0.75 times 0.5 times negative 4.6 and then have that times x. Then we could take 0.75 times 0.5 times 53 and have that added to it and then have that in replace of this. And then that would all over be this. And then we could, simplify that if we wanted to even more and get rid of the square root in the denominator and rationalize it and do all that. But I think right now what we want to do is just leave it here. So now what is going to be the rate of change when x equals 12? So then what we want to do is we want to find ds dx, and that's going to be when x equals 12. So now we're going to plug that in. And so ds dx when x is equal to 12, that's going to just be our 0.0 no 75, not 0.75. Now let's get rid of that while we're at it. So it's 0.75 times our 0.5, and then that was times our negative 2.3 x squared, so 12 squared, and then plus 53 times 12 plus 250, and then that's all to the negative 1/2. And so then we have, and I could just put the parenthesis there, that way it's just that. And then now I have the negative 4.6 times 12, and then plus the 53, okay? Now we got to plug all that into our calculator. So let's clear that out. So we have the 0.75 times 0.5 times, and now we have the negative 2.3 times 12 squared plus 53 times 12 plus 250 and parenthesis raised to the negative 0.5, arrow back down, and then it was times negative 4.6 times 12 plus 53, and then enter, negative 0.035. So I think that's all I'll use. And so this is equal to negative 0.035, and that's going to be $1,000,000 per month. That's going to be changing. So it's going to be decreasing by $0.035 million per month. Okay. And so that would be how we do that one. All right. So I'll pause and then we'll come back to this one.